our next presenter is once again Jeremy Seeger with EPA Region 6, and he will be talking about EPA rules and requirements for closure of earthen manure storage structures. Jeremy.
Thank you, Saqib. This topic is something that may seem burdensome to people. It may be a task that's unwanted and may follow a facility closing for one reason or another. And it may also seem to not be a favorable topic that needs to be discussed, but if not handled properly, these lagoons or earthen manure storage structures can be a ticking time bomb. I'll briefly discuss the regulations that are associated with a closure, talk a bit about the CAFO program, when EPA may become involved, what would EPA's involvement be. I got a couple examples I'll share, and then I'll follow up, finish up with some resources. There are two federal statutes that can be cited as having jurisdiction over the closure of a lagoon. Under the Clean Water Act, Clean Water Act says it's unlawful to discharge any pollutant from a point source to the waters of the U.S. unless a permit is obtained. And the other one is the Safe Drinking Water Act, which protects public health from contaminants in drinking water. Under 40 CFR 122.23 states, talks about the duty to maintain a permit coverage until the permittee or the facility has demonstrated to the satisfaction of the director or the permitting agency that there is no remaining potential for a discharge of manure, litter, or associated processed wastewater that was generated while the operation was a CAFO, other than agricultural stormwater from land application areas. And the other regulation that EPA will use to address proper closure of lagoons are the state regulations. The federal CAFO regulations do not specifically address the closure process of an earthen manure storage structure. However, the federal regulations that I mentioned in the previous slide do prohibit surface water and groundwater contamination, and that does extend to earthen manure storage structures, whether they're in operation or in a closure process. Most of the states have been delegated the NPDES CAFO program. However, EPA retains oversight authority of the program. Most closures of an earthen manure storage structure does not include the involvement of EPA. Generally, a closure is handled by the state agency that has been delegated the CAFO program, and they will work closely with the NRCS, the universities, or other state agencies that may have an interest. If EPA does get involved, if they do get involved, some of the triggering items that would trigger EPA to get involved would be those states where EPA is the current permitting authority. If the state or facility requests EPA's assistance or involvement in a closure, if there have been ongoing enforcement actions or a history between a facility and the EPA, or if there are egregious issues involved with a closure plan, and some of those may even be political issues. If EPA does become involved in a closure plan, some of their involvement, would be commenting or approving a closure plan, ensuring that a nutrient management plan is suitable, making sure that it demonstrates that the lagoon contents are going to a place that is for beneficial use, installing monitoring wells for pre- and post-closure monitoring, typically looking for nutrients and bacteria, nitrogen, phosphorus, and E. coli, I guess, would be the primary bacteria looking for. Or to set target concentrations for nutrient concentrations in the soil following an excavation of a lagoon. I've got a couple examples that I'm going to share with you. The first example involves a lagoon closure where we partnered with our state counterparts and converted a lagoon into a freshwater pond. It was an earthen lagoon. It had not been used for 3 to 4 years. It was determined that it was approximately 30 to 40 years old. There was no history or design, history on the design and construction of the lagoon. It was located on fractured granite. There had been identified seeps around the slope in multiple locations. So the facility installed 4 monitoring wells, 1 up gradient and 3 down gradient of the lagoon. There were 2 down gradient monitoring wells that showed that they had significantly elevated ammonium and bacteria. It was a very large lagoon. Actually, it was multiple lagoons in one area. It included about 140 acre-feet of material was removed. It came to our attention later that about 350 semi-truckloads had to be moved twice. It had been moved to one location, and because it was being spread out about a foot thick on some land, they were required to haul it back, stage it until another suitable location was identified, and that cost of that closure exceeded $2 million. Another example of a closure plan that we got involved with, and again we partnered with our state counterparts. This facility again had no design or construction information was available on a series of 3 lagoons. In 2009, we collected surface effluent analysis of the lagoon and had a concentration of 240 ppm nitrogen or 35 parts per million phosphorus. And between 2009 and 2011, there was starting to phase out the operation of this facility. This was a washwater lagoon for a poultry operation. So between 2009 and 2011, they were in the process of phasing out animals there. In early 2011, we collected effluent samples, and the concentration had decreased significantly down to 63 parts per million nitrogen and 8 parts per million phosphorus. But whenever they started digging that out, they were able to get a solid manure analysis that has highly elevated nitrogen and phosphorus concentrations of 22910 and 2550 phosphorus. That was several feet of material was removed out of there, and it had approximately 50 years of accumulation. I know these numbers are not as concentrated as you would see at a typical facility that receives more manure. This is again just for a washwater at an egg-laying facility. Following the removal of the initial solids and liner material out of there in late summer 2011 this year, samples were collected of the soil below the liner, and the soil concentration was 600 parts per million ammonium and 458 parts per million phosphorus. So they removed an additional couple feet of soil was removed out of there, and you can see there that the concentrations had decreased significantly down to 3 parts per million for both ammonium and phosphorus. That concludes my segment of today's topic, and I've included some resources there that I would encourage you to take a look at and explore. And again, I also want to thank you for making time to watch this presentation. Saqib, that's